Hi friends, in this lecture video, we'll learn about minus, cofactor and determinants. In the previous lectures, we have seen what is matrix and types of matrix and some of their basic operations, namely addition, subtraction, scalar multiplication and matrix multiplication. So, to find the determinants, minor and cofactors are playing a major role, and to find the inverse also, you should know how to find the cofactor. So, first we'll learn how to find the determinant of a small matrix, that is 2 by 2 matrix. So, determinant, a square matrix which can associate with a determinant is determinant A or modulus A or del. Find the determinant of, they have given some matrices. So, for the determinant, if you want to find a determinant of a matrix, that must be a square matrix. What do you mean by a square matrix? A square matrix is nothing but order of, that means the number of columns and rows are same. So suppose a matrix is of order n by n, then the number of rows is n and number of columns is also n. So then we can say this as a square matrix. Suppose there is a matrix m by n, then the number of rows are m and the number of columns is n. So they are not equal. So we can call that as a rectangular matrix. So to find the determinant, the matrix must be a square matrix. So look at this example. So they have given it is 5. So 5 is nothing but 1 by 1 matrix, only one row and one column. Similarly, for minus 13 also only one row and one column. Look at this problem. There are 2 rows and 2 columns. So it is a 2 by 2 matrix and these are all 2 by 2 matrix. Right? Now we are going to find the determinant of this matrix. So first I am taking my capital A is a matrix 5. If I want to find the determinant of this, then I have to write the A in the modulus. So determinant of A is 5. It is nothing but that number itself. The matrix B is minus 13. So determinant of B is, it is not modulus, it is determinant. So you have to write minus 13 itself. So the determinant can be negative, positive or either 0. So you cannot constrain this determinant as to be a positive one. It can be negative or 0. So the next one, very important. C is a matrix A, B, C, D. Then determinant of C. So I am going to teach how to find the determinant of a 2 by 2 matrix. For that, you should multiply the elements in the primary diagonal and you have to multiply the elements in the another diagonal, then subtract both of them. So this is the primary diagonal. So this is the primary diagonal. So you have to multiply this first. So AD minus what is the another diagonal, that is BC. So you have to find the solution, that means the product. You have to find the product of the another diagonal, that is BC. So AD minus BC is the determinant of C. Then we'll move to the next problem. D is 8, 2, minus 3, minus 1. So modulus of D is nothing but 8 into minus 1 is minus 8, or else I just expand it. So 8 into minus 1, okay, minus 2 into minus 3. So this would be equal to 8 into minus 1 is minus 8, minus 2 into minus 3 is minus 6. So it will be minus 8 plus 6, that is minus 2. Then E. What is E? E is the matrix is minus 2, 1, 7 and 6. So what is determinant of E? Determinant of E is equal to 6 into 2. 6 2s are 12. So it is minus 12. Put a minus sign. 1 7s are 7. That is also positive. So minus 7, which is equal to minus 19. So the matrix, if you want to find the determinant of a matrix, that must be a square matrix. For a 2 by 2 matrix, you have to multiply the primary diagonal and the another diagonal, then you have to find the difference of that. Okay, so this is known as a determinant. Then we'll move to the minor. Minor of an element of the determinant is the value of the lower order determinant obtained by deleting the row and column which contains the element. So it is very important thing, deleting the row and column which contains the element. So we are going to eliminate particular column and row which the element lies, and we can find the minor value, that means the smallest determinant value which we can obtain. So minor of the element Aij is denoted by capital Mij. Then we have deal with the cofactor also. Cofactor is nothing but minus 1i plus j. Minor is the cofactor. So you have to find the minor value and you have to substitute the formula, that is minus 1 the whole power I plus j into minor, that is known as a cofactor. For example, I am taking a matrix capital A. The elements are A11, A12, A21 and A22. Right? So this is the given matrix A. So now I am going to find the minor of that. So it must be a square matrix because then only you can find the determinant, right? So A is equal to A11, A12, A21, A22. I am going to find the minor of that. So minor of first element, that means A11. For that, you have to eliminate the corresponding row and column of that A11 lies. So we look at this. A11 lies here, A11 lies in the first row and the first column. Eliminate these two. So we are getting A22. So A22 is nothing but the minor of A11. Right? Similarly, we are going to find the minor of other elements, that is minor of A12, minor of A21 and minor of A22. So for this we are going to do the same procedure and we'll find. Again we have to find the cofactor. So cofactor of A11 and a cofactor of A12, cofactor of A21, then cofactor of A22. So we are going to find these four values. That means a minor one cofactor. Okay. So for we are going to deal with minor of A12. So what will be A12? So for A12, it is A12. So it is lying in the first row and the second column. So what is the element which we left? That is the element here A21, right? So we have to enter the value of A21. Is A21. So what is the value of A21, minor of A21? So finding minor of A21, we have to eliminate the corresponding row and column which it lies, right? So see, A21 is the element, right? It lies in the first column and the second row. If I eliminate these things, I'll get A12. So minor of A21 is A12, right? So I have to enter A12. And what is the minor of A22? It is very simple. When you look at here, A22, you have to eliminate the corresponding row and column. That means the second row and second column. You left with A11. So now you know how to find the minor of this. So cofactor is nothing but there is a formula and the minor same. So you just write the minor value as it is, that is A22, A21, A12 and A11. So now we are going to find whether it is positive or negative. For that we have to use this formula. See what is I and what is j, that you have to find here. So your I is 1 and j is 1. I is 1, j is 2. I is 2, j is 1. I is 2 and j is 2. So we are going to use the formula. The formula is minus 1 the whole power ji plus j. Right? For the first one, it is minus 1 the whole power 1 plus 1 because a11. I is 1 and j is 1. So it is equal to minus 1 the whole square. Minus 1 the whole square is positive. So this term is positive. And for the next one, cofactor A12. So minus 1 the whole power 1 plus 2. So minus 1 the whole power 3. So it is an odd number. So you will get minus 1. So the value, the cofactor of A12 must be minus A21. Right? And for the cofactor of A21, it's again minus 1 the whole power 2 plus 1. That is minus 1 the whole power 3. Again it is negative. So it is negative. And cofactor of A22, minus 1 the whole power 2 plus 2. It is minus 1 the whole power 4. So it is positive. So 1. Right? Positive. So now we know that these two values are getting negative, remaining values are positive when you find the cofactor, and minor you have to eliminate the corresponding row and column, right? Hope you understand this. Now we will move to the next problem so that you can understand how to apply this minor and cofactor concept. So find the minor and cofactor of the matrix. So they have given 3 minus 2, 5, 0. Now we are going to find the respective places, that means the respective minor and cofactors. Solution: minor of 3, minor of -2, minor of 0 and minor of 5. So that is what we are going to find. Then we'll move to the cofactor. So cofactor of 3, then cofactor of -2, cofactor of 5, then cofactor of 0. So okay. So what is minor of 3? You have to eliminate the corresponding row and column. That means you have to eliminate the first row and first column. Only element left with is 0, right? So you just enter the 0. And minor of -2, you have to eliminate the corresponding row and column. You left with 5. Minor of 0, you just eliminate the corresponding row and column. The element is 3. And minor of 5, you eliminate the corresponding row and column, you are left with -2. And for the cofactor, you just enter the same value, that is 0, 5 and 3 minus 2. So now we are going to check what will be the positive and negative values. We know that by the previous derivation, these two values will get negative. So I just put negative here, so it is minus and minus of minus, so it will be -5 and 2. These are the cofactor. This is the difference between the minor and cofactor. So in the previous derivation, I found that I could replace the values of A12 and A21 with negative, so that directly I can apply it in the further problems. So I just applied this concept here. This value and this value will be negative. So what will we do in the 3 by 3 matrix, that we learn? Okay. Find the minor and cofactor of the matrices. So it is very simple. Again, you are going to do the same process, minor and cofactor, and we are going to eliminate the same things, right? So now, at what places you have to put a negative sign? For that, I just give a clue. These are the values you have to put negative sign for the cofactor. When the cofactor concept arrives, you have to put negative sign, or otherwise these are all same. Okay. Please understand that when the cofactor concept arrives, these places will be negative, remaining are positive. Why I am saying these are all negative? So this is, look at here, now it is of the place A12, right? It is A12. So A12 means -1 the whole power 1 plus 2. So it is -1 the whole power 3. So it will be negative. And this is of a place A21. So minus in the whole power 2 plus 1. So it is minus in the whole power 3. So it will be negative. And this is of the place A23. So it is minus on the whole power 2 plus 3. It is minus on the whole power 5. It is negative. And similarly, it is, it is minus on the whole power 3 plus 2. And it is negative, right? So that's why I told whenever there are 3 by 3 matrix, please put a negative sign when you find the cofactor for these places, right? These positions. So let's move to the problem solution. It is a little bit tricky because you have deal with 2 by 2 matrix and what you are going to do with 3 by 3 matrix. So first I'll teach you how to find a minor of first element that is 6. So minor of the element 6, that is A11 position. So what is our rule? We have to eliminate the corresponding row and column. So you just eliminate the row and column, you will get 1, 3, minus 1, 6. So that you could find the determinant. So what will be the determinant? So 1, 6 are 6, put a minus sign. 3 ones are 3, there is a negative sign. So minus 3, so it is 9. So minor of 6 is 9. So minor is nothing but you have to eliminate the corresponding and row and column, and you have to find the minimum determinant. That means either it is a 2 by 2 matrix or 3 by 3 matrix or 5 by 5 matrix. You have to eliminate the corresponding and row and column. You just find the determinant of the remaining part. That is the concept. So for finding the minor of 6, I am eliminating the row and column. That means the first row and first column. I will get 1, 3, minus 1, 6. They are 2 by 2 matrix. I just find the determinant. It is 1, 6 or 6. Put a minus sign. And 3 ones are 3. There is a minus 1. So minus 3. And it will be 9. Then we can proceed in the further way to find the minor and cofactor of the remaining. So minor of 4. That is nothing but eliminate the corresponding row and column. That is second column and the first row. You will get 7, 3, 0, 6. So the determinant say 7 6 are 42 minus 0. So it will be 42. Then minor of 2. For the 2 you have to eliminate the third column and the first row. So it will be 7 1 0 minus 1. So it will be minus 7 minus 0. So it is equal to minus 7. Then minor of 7. For 7 you have to eliminate the corresponding row and column. This is our element, right? 7 which lies in the second row and the first column, right? This is our 7. So you just eliminate the corresponding row and column. So you'll get 4 2 minus 1 6. Similarly you have to do, so it will be 4 2 minus 1 6. When you find the determinant, 6 4s are 24, minus is there, and 2 into minus 1 will be minus 2, so it will be 26. Then minor of 1. For 1 you have to eliminate the corresponding row and column. You will have 6 2 and 0 6. So it will be 6 6 are 36 minus 0. So it will be 36. Then minor of 3. So that is determinant. Minor of 3, no, it is 3. You just eliminate the corresponding column in the row, right? You'll have 6 4 0 minus 1. So it is 6 4 0 minus 1. So when you find the determinant, it will be 6 into minus 1 is minus 6, minus 0 it is minus 6, right? And now we will find the cofactor. So cofactor of 6 is, it is positive, so it is 9 itself. And cofactor of 4, and we know that in 4 is in the place of a 1 2, so it will be negative, so minus 42. Then cofactor of 2, so it is in the position of a 1 3, so it will be positive, that is equal to minus 7. And cofactor of 7, that is in the position of a to 1, so we'll put a negative, so it is minus 26. And cofactor of 1, and it is in the position of a to 2, so that will be positive, that is 36, right? And cofactor of 3, that is the position of a to 3, so that is negative, we know that is negative, right? So it is minus of minus 6, it will be positive 6, right? We can find the similar way for the last row. So minor of 0, you just eliminate the corresponding row and column, you left with 4 2 1 3, and it will be 12 minus 2, that is equal to 10. And minor of minus 1, so eliminate the corresponding row and column, it will be 6 2 7 3, so it is 18 minus 14, that is 4. And minor of 6, eliminate the corresponding row and column, right? This is the third row and third column, so left with 6 4 7 1, so it is 6 minus 28, that is minus 22. So you can find the cofactor. So cofactor of 0 is, just eliminate the you just find the value, that is minus 1 the whole power I plus j. It is in the position of 3 1, so 3 plus 1 will be 4. When it is a even number, that will be positive, so it is 10 itself. And we know that this is the only negative part, so cofactor of minus 1 is minus 4, because of it is in the position of 3 2, 3 plus 2 is 5, it is odd number, so it will be negative, so minus 4. And cofactor of 6 is minus 22. Okay, so these are all the main points. So how to find the cofactor and minor, right? Yes. We'll move to the next thing. Find the determinant of a given matrix. So we know how to find the determinant of a matrix. So determinant of a 2 by 2 matrix, you know. For a 3 by 3 matrix, you have to select any one of the row and column. You have to find the cofactors of that and you have to add all those things. That's it. So you know what is cofactor and you know how to find the cofactor also. The combination of a cofactor in a particular row or column will gives you the determinant. Either you can select any row or column, the value of the determinant must be same. Okay, so solution. So for I am taking the first row. So the first row, what is the first element? So I just consider this as a matrix A. So matrix A is 6, 4, 2, 7, 1, 3 and 0, minus 1, 6. Right? This is matrix A. So for the determinant, it is determinant of A is equal to, write the first element as it is 6 and write the cofactor of that. What will be the cofactor? It is 1, 3, minus 1, 6 because you are eliminating the respective column and respective row, right? And what will be the next element? That is 4. We know that it will be negative. By the cofactor formula, it is negative, right? So minus 4 and you have to eliminate the corresponding row and column. You will get 7, 3, 0, 6. Similarly, for the last element, that is 2 and you know it is positive. And if you eliminate the corresponding row and column, you will get 7, 1, 0, minus 1. So what is the procedure? You have to take any one of the row or column. Whatever may be the row or column, you'll get the same answer. So you have to select any one of the row or column. You just write the first element and find and write the cofactor along with it. Then write the second element and write the cofactor along with it. Write the third element and the cofactor along with that. That's it. If you find the sum of all these things, you'll obtain the determinant of that matrix. So this is equal to 6 into 1 6 are 6 minus 1 into 3 will be minus 3, right? Minus 4 into 7 6 are 42 minus 0 plus 2 into 7 into minus 1 will be minus 7 minus 0. So this is equal to 6 into 6 plus 3 is 9 minus 4 into 42 minus 0 will be 4 into 42. So it is 4 into 42 and 2 sevens are 14. So it is minus 14. So it is 9 6 are 54 and 4 42s are 168 minus 14. So we know that it is 54 minus 14 is 40 and minus 168 plus 40 will be minus 128. So this is the final answer, minus 128. As I said, the determinant can be negative or 0 or positive. So you cannot restrict that, it should be positive, right? We'll move to the next problem. So if find x if the determinant is 0. They have given the determinant itself and the value of the determinant also, that is 0. So we are going to find x. So I am going to do the same procedure. I am selecting the first row, right? This is the first row. So what will be the determinant? 1 into determinant of this matrix is 3 0 minus 4 8 and put a negative sign in the second element. Eliminate the respective column and row. You will get 5 0 minus 2 8. And for the third element, it is minus 4 into, eliminate the respective row and column, you will get 5, 3, minus 2, minus 4, right? And we know that this is equal to 0. So when you make this to be equal to 0, you can find the value of x, right? So this will be 8 3s are 24. So it will be 24 minus 0 minus x into 5 8s are 40, 40 minus 0 minus 4 into 5 4s are 20 and that is minus 20 minus of 2 3s are 6, so it is minus 6, that is equal to 0, right? 5 4s are minus 20 and 2 3s are 6, so it is a minus of minus 6. So 24 minus 0 is 24 minus x 40, so it is minus 40x minus 4 into minus 20 plus 6. So minus minus plus, so it is minus 20 plus 6, it is minus 14 equal to 0. So when you find the value minus 14 minus 14 into 4 will be into minus 4 will be 4 4s are 16, 1 and it is 56. A minus into minus will be plus. So it is plus 56 plus 24. So it will be 80, right? So it is 24 minus 40x plus 56, that is equal to 0. So when this minus 40x go to another side, that will be plus 40x, and 24 plus 56 will be 80. So 80 is equal to 40x, and your x is equal to 80 by 40, and that is 2. So x is equal to 2. Hope you understand the concept of minor, cofactor and determinant. Okay. I'll meet you in the next video lecture with the concept of adjoint and inverse. Thank you for your patience. Thank you.